Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In episode 18 of the Network Plus Prepcast, we turn our attention to the core functions of switch ports, how they are configured, monitored, and used in real-time diagnostic scenarios. Switch ports are more than just physical access points. They define how data enters and exits the network. Proper configuration is essential for controlling behavior, enforcing access, optimizing performance, and ensuring the integrity of traffic flow at the access layer. Getting port configuration right is one of the foundational tasks in any network deployment, whether you're working in a small office or a large enterprise. Port mirroring is another critical topic we cover in this episode. It enables traffic analysis without interrupting production systems. Port mirroring duplicates network traffic from one or more interfaces and sends that copy to another interface on the same switch or even across switches for analysis. This functionality is indispensable for troubleshooting, capturing security incidents, and conducting performance monitoring. Used correctly, port mirroring offers a powerful window into what's happening on your network at the packet level, all without interfering with live traffic. At the most basic level, port configuration begins with defining how a port communicates with connected devices. Speed and duplex settings are two of the most critical parameters. These settings determine whether a port operates at 10, 100, or 1000 megabits per second or faster, and whether it transmits data in full duplex or half-duplex mode. Auto-negotiation is commonly used to allow the switch and endpoint to determine the best settings automatically, but manual configuration may be required in cases of interoperability issues or when precise control is needed. Misconfiguration here can lead to degraded performance or dropped packets. Every port on a managed switch must be configured either as an access port or a trunk port. An access port carries traffic for a single VLAN, typically connecting to a user endpoint like a desktop or printer. A trunk port carries traffic for multiple VLANs using 802.1q tagging to identify each frame's VLAN membership. Trunk ports are used for switch-to-slip connections and for links to routers or wireless controllers. The distinction between access and trunk is made in the interface configuration, and applying the wrong mode can break connectivity or lead to serious segmentation failures. Switch administrators often need to enable or disable individual ports. Ports may be administratively brought down to isolate a misbehaving device, to protect unused ports from unauthorized access, or simply to conserve power. This is commonly done using an interface shutdown command. Conversely, bringing a port back up can be used as a troubleshooting tool, especially after cabling or hardware changes. Managing the administrative status of a port is one of the quickest ways to exert control over what devices are allowed on the network and when they are active. Port descriptions are a simple yet powerful tool for switch management. By labeling each port with a description, such as HR printer, marketing PC, or VoIP phone, administrators make it far easier to troubleshoot and audit the network later. These descriptions appear in various show commands and help engineers identify what is connected to each port without manually tracing cables. In large networks with hundreds or thousands of switch ports, consistent and meaningful port descriptions save time, reduce errors, and make documentation far more effective. Interface errors and counters are used to detect problems on switch ports. Common counters include input and output errors, cyclic redundancy check failures, late collisions, and frame drops. These metrics help diagnose issues such as damaged cables, speed mismatches, or duplex conflicts. A sudden increase in error counters is often the first clue that something is wrong. Most switches maintain these statistics for each interface and can display them with diagnostic commands. Regular monitoring of these counters helps catch problems before they affect end users. Speed and duplex mismatches are particularly common and often go unnoticed until users begin experiencing slowness or intermittent connectivity. If one end of a link is set to auto and the other is set to a fixed speed or duplex, the link may default to half duplex, leading to collisions and reduced throughput. These mismatches can result in dropped packets, retransmissions, or erratic behavior. Diagnosing and resolving them involves inspecting both ends of the link and confirming that speed and duplex settings match, or that both sides are properly negotiating. Port mirroring, also known as SPAN, switched port analyzer, is used to duplicate traffic from one interface and send it to another. This allows traffic to be analyzed using packet capture tools such as Wireshark, intrusion detection systems, or performance analyzers. SPAN can mirror ingress traffic, egress traffic, or both. It provides a real-time, non-invasive method to inspect packet headers, application flows, or low-level errors without interrupting the original data stream. This functionality is essential for diagnosing complex issues or observing behavior that cannot be captured through logs alone. Port mirroring is especially useful in several key scenarios. In security analysis, mirrored traffic can be reviewed for signs of malware, suspicious activity, or policy violations. During troubleshooting, administrators can capture real-time packets to isolate problems that occur only intermittently or under specific conditions. For performance monitoring, mirroring allows deep inspection of how applications behave across the network, helping identify latency issues or excessive retransmissions. All of this can be done without taking devices offline or disrupting critical services, making mirroring a go-to tool for network professionals. Configuring SPAN or RSPAN remote SPAN involves selecting the source port, or VLAN, from which traffic will be copied, and designating the destination port that receives the duplicate packets. SPAN operates within a single switch, while RSPAN can carry mirrored traffic across trunk links to another switch using a special VLAN for transport. This makes it possible to centralize monitoring in large environments. Selecting the correct source, direction, ingress, egress, or both is essential, as is ensuring the destination port is connected to the appropriate analysis tool. While port mirroring is a powerful tool, it's not without its limitations. One common issue is switch CPU load. If too many sessions are mirrored, or if the source port is handling high-speed traffic, the additional overhead of duplicating those packets can strain the switch's processor and affect performance. Another limitation is that the destination port can be overwhelmed if it receives more mirrored traffic than it can process. This could lead to dropped packets and incomplete captures. By default, most mirroring configurations capture all traffic from the specified port, or VLAN, meaning no filtering is applied unless done at the capture tool itself. Mirrored traffic includes all packets observed on the source port unless otherwise specified. This includes both user data and protocol overhead. Some switches allow you to narrow the mirrored scope by enabling VLAN-based mirroring or direction-specific capture. For example, you might configure a port to only mirror ingress traffic or only traffic related to a specific VLAN. Fine-tuning what gets mirrored is important for conserving resources and reducing analysis complexity. However, if this filtering is not configured carefully, important packets may be missed, or the analyzer could receive unnecessary data. Port mirroring is commonly used in compliance environments where traffic logs must be captured and retained for audits. This may involve recording all communications to and from specific devices for regulatory review. Mirrored traffic can also be archived for long-term inspection, useful in forensic investigations after a security breach. When integrated with platforms like SIEM systems or intrusion detection solutions, mirroring becomes part of a larger security posture, feeding critical packet-level data into systems designed to detect anomalies, generate alerts, and even trigger automated responses. There are several best practices for managing ports and monitoring traffic. First, administrators should always disable unused ports. This not only reduces the attack surface, but also makes it easier to identify unauthorized devices. Second, if devices experience instability due to negotiation mismatches, it may be wise to manually set speed and duplex. This ensures consistent behavior and avoids auto-negotiation quirks. Third, every port should be clearly labeled with a descriptive name, both physically and within the switch's configuration. This makes it easier to identify devices during audits and supports faster incident response during troubleshooting. Ports must also adapt to changing conditions. Link flapping, where a port repeatedly goes up and down, may require administrative intervention to stabilize. Switches often log such events, and corrective action may include replacing cables, adjusting negotiation settings, or upgrading firmware. Speed renegotiation may occur when a new device is connected or when a port recovers from a failure. It's important to understand how these dynamic behaviors work and how they affect link stability. Ports that are misbehaving may also need to be administratively shut down and reassembled after repairs or changes. Remote monitoring using techniques like RSPAN introduces additional considerations. The mirrored data must be transmitted across a trunk, meaning the trunk must support sufficient bandwidth to carry both regular network traffic and the mirrored stream. If the mirrored traffic includes high throughput flows, such as large file transfers or video streams, those packets could saturate the trunk and degrade performance. Configuring a dedicated RSPAN VLAN helps isolate the mirrored packets, but care must still be taken to ensure that destination ports and analysis tools can keep up with the mirrored traffic volume. Several tools rely on port mirroring to function effectively. Packet sniffers like Wireshark allow administrators to examine every byte of mirrored traffic in real time. These tools are invaluable for deep packet inspection and protocol analysis. Network performance analyzers use mirrored data to detect application layer delays, retransmissions and connection resets. Intrusion detection systems scan mirrored traffic for patterns associated with known threats, scanning every packet to identify suspicious behavior. Without mirroring, these tools would lack visibility into the data flows that define network behavior. Ultimately, port configuration and mirroring are foundational to effective network management. Port settings determine how devices connect, communicate, and behave under changing conditions. Mirroring, on the other hand, provides diagnostic visibility, duplicating traffic for analysis without impacting production systems. Together, these capabilities allow administrators to enforce control, improve uptime, and maintain the health and security of the network. They are essential tools for any network professional and a key part of day-to-day operations in both small and large infrastructures. To recap, switch port configuration determines how interfaces behave at Layer 2 and Layer 1. Administrators control speed, duplex, VLAN roles, and administrative status. Errors and statistics help diagnose issues, while descriptions improve documentation and support. Port mirroring enables traffic duplication for analysis, supporting troubleshooting, compliance, and security monitoring. Whether using SPAN for local captures or RSPAN for remote visibility, the ability to monitor traffic without disrupting normal operations is an essential function in every network environment. Mastering these skills is vital for certification and for real-world success in networking roles. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.